Hey there, we're going to go over the solutions to the Kahoot that I assigned for volume. And if you have not yet done this Kahoot, you should do the Kahoot first. And then, yeah, that's what you should do. So first question, you were asked to find the area, not volume, just area. All right, this is actually a good warm-up question to see how good you are with just finding area in between two curves. So guess what? You can take this, you can graph it in Desmos. Why not? It gives you the intersection points. If you click on them, it's nice. So to find the area, you have to be a little bit careful because you are switching between one curve and the next with this absolute value. This curve up here is y equals negative x when x is negative, and this is y equals positive x. So you have to be careful there. All right. We're going to sweep along in the x direction. All right. That's definitely how you want to do this problem. Sweep along in the x. So since we're sweeping in the x, we have dx. All right. Everything's in here should be in terms of x. Your bound should be in terms of x. We're going to start at -1, but we're just going to go to 0 because we are following this curve here. All right. And then we have to switch. We have to do a second integral for this curve over there between 1 and 3. All right, that's a separate one that we need to do. So for this one, because we're finding these areas in here, you do the uppermost function minus the bottommost function. So the uppermost function, you have to solve this thing in terms of y. And when you solve that in terms of y, you should get y equals x plus 3 all over 2. So this is x plus 3 all over 2. And you're subtracting the bottom function. The bottom function is negative x. So, or you can say plus x instead of minus negative x. And then for this one, you're doing the same thing. The topmost function is x plus 3 over 2. Again, the bottom function is just plain old x, so you're subtracting x. Now you can, if you want, just plug that into your calculator and get 3 out as your answer. Done. Second one, find the area between these two curves. Again, go to Desmos, graph it. Now we do not want to sweep in the x direction. We're going to want to sweep in the y direction, all right? Because the y direction is going to give us the two bounds as our function. If we try doing the x direction, that's going to be gross. And it's possible, but you don't want to do it. All right, so everything's in terms of y. Now, because our functions aren't changing at all right, we can just sweep the whole thing along in the y. So everything's in terms of dy. All your values in here need to be in terms of y, all right? And your starting value to your ending value are your y values. So we go from -1 to 2, y values. All right, our outermost function is this guy right here. So that is this one here. We need to solve for it in terms of y. So that would just be x equals y plus 2. So y plus 2 is our outer function. Our inner function is this one here, all right? It is already solved in terms of y, x equals y squared. So you just do minus y squared dy. And again, take that, plug it into your calculator, and you get your answer 9/2 done. Now we're getting to some volume problems. You want to find the solid. If the base of an ellipse has cross sections perpendicular that are squares. Once again, you can take this ellipse, you can plug it into Desmos. All right. Perpendicular to the x-axis. Here's my x-axis. Everything perpendicular is a square. So it's like this line right here would have a square coming up. It's like you're looking down, bird's eye view. All right. And you just have all these squares popping out of the page. All right, so you're looking straight down at it. It is coming up at you, and they're all squares. All right, so anytime you do a volume problem, it's always the integral of your area dx, all right, or dy. But it's always, you just find the area of a cross-section piece and sweep it, all right? In this case, anytime you're doing it perpendicular to x-axis, you're going to sweep it along the x-axis, all right? So, these are all squares. So basically what you have to do is you take your integral. We're starting at -3 and going to 3. So -3 to 3 of dx of whatever my base is, this whole entire base squared. All right, because I want the area is going to be side length squared. So I need to figure out what this side length is. So the first thing I need to do is solve for what is this piece right here. Well, that's just solving this. Y equals whatever in terms of x. You can let your calculator do that. But then that only gives me half of it. Then I need to double it. So it's 2 times whatever my function is in terms of x, dx. Everything's in terms of x. So in your calculator, you can solve this. You just solve comma y. So it'll put it y in terms of x. So here it is in terms of x. You take that, you put it down here, but you have to double it for the top and the bottom, right? Because you have the top here and then the bottom down here. You square that whole thing. Don't forget to square it. And you go from -3 to 3. And you get your answers 64. You're done with that one. Next one. Find the region under a graph y equals square root of x above the x-axis over the interval 4 to 9 if it's rotated around the x-axis. All right. So again, you can plug it into Desmos. All right. Here's your square root function. We're going from 4 to 9. Now, if we're rotating it around, we're getting circles. All your rotation ones, discs, washers, it's circles, 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 circles. So it's always the area of a circle, all right? It's still my area, in this case, dx, but area is just pi r squared. R is my function. That's really all you got to do. So we're going from 4 to 9. Everything's x, dx. 4 x value 9 and pi times my radius squared. My radius is just, in this case, it's nice and easy. It's my function. That's the height of my function. So that's just the square root of x. You could just square the square root right off the bat to save yourself a little bit of time. I decided to just write the whole thing out so you could see it. And there it is in your calculator. There is your volume. Number 5. Find the area below the region of y equals x squared, but above the line y equals -x. So you're not going all the way to the x-axis. You're going down even more, which is a little bit weird. This isn't your typical kind of problem. It looks like a washer problem. It's actually a disk problem because you're filling in that middle part. And you're going from 1 to 4 because you're rotating it around y equals -1. So you're rotating it around this line down here, right? From 1 to 4, so that goes up a little bit. So this rotates around, right? This rotates around. The whole curve is just going to be a complete reflection of itself. This is going to rotate around. It's kind of hard to visualize, but you get circles, 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 circles. All right. So once again, we're doing it in terms of x. So we're going to do my area dx. My area is pi times r squared. For x's, I'm going from 1 to 4. All right. So this is whatever my big radius is. All right. My radius, though, is from this line all the way up. So I have to first go up 1 just to get to there. I have to go up 1 first. So my radius is going to be 1 plus whatever my function is in this case, which is x squared. So I just take that, I plug it in for my r, I square that times pi, and then I sweep it by taking my integral. And if you plug it into your calculator, you get the following, and you get the right answer. The next question. Now you want the region bounded by the y-axis in the graph y equals 3 and y equals the square root of x. You're rotating it around the y-axis, all right? If you're rotating something on the y-axis or any vertical line, now it's dy's. Everything's dy. So first, you can go to Desmos, and you can graph it. And if we rotate this around, it's going to basically be like a reflection on the other side, and these will all be these circles going throughout, all right? So it's just like this kind of funky cone shape. But we're doing it in dy. So we're going dy integral, all right? My y value is 0 to 3, right? It's circles, 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 circles. An area of a circle is pi times r squared. What is my r, though? My r is going to be something in terms of y. Notice it's right now y is in terms of x, so I just change that around and make it x equals y squared. All right. So I just plug in y squared for my r, and then again you can plug it into your calculator. All right. There's my pi big R squared from 0 to 3, and you are done. Next problem. This is another rotation problem, but we're rotating around line x equals 5. Oh boy, this is kind of a crazy one because x equals 5 is way the heck over there. And if you graph these things, you'll notice you have this interesting little curve here. So here's my origin, just to get your bearings straight. There's my origin. This is 5. So that's what we're rotating it around. And here's the region, all right? All these pieces in here are going to get rotated around to the other side. So they're going to get rotated over here. This whole thing is going to look like some interesting cone that's mostly hollow. This is a washer problem. All right. So we're rotating it parallel, something either the y-axis or something parallel y-axis is going to be dy's. All right. So I'm going to have I'm going to just put my dy way the heck over here. Give myself plenty of space. All right. My bounds are my y values, not x, y. 1 to 3. So I'm going 1 to 3. Pi big R squared. I don't know if I want to. Yeah, I'll just write it like this. Minus pi little r squared. So far so good. That's not that bad. All right. My big R and my little r have to be something in terms of y. So my big R, if you look at your big radius is going to go all the way to the red function. All right. So I need to figure out what that distance is. That's a tricky distance to find because this distance here is based on my function, but I need to solve for that. So what would that be? That would be x in terms of y. So in this case, this would be x equals, it looks like y squared minus 1 over 2 if I solve this guy in terms of y. But that's this distance. And this whole distance is 5. So this is the difference. All right? That's 5 minus y squared minus 1 all over 2. I know it's kind of messy, and that whole thing is getting plugged in and being squared. My little r, you find it the same way. To find the distance from here all the way over, from this line over to this line, again, you have to go all the way back to the origin, or back to the y-axis. So you go 5. It's, oops, I'm just plugging things in, I guess. This little r is 5 minus this distance, but you have to solve for this thing in terms of y. So that's 2y minus 2. All right, that one's kind of gross. Hopefully you don't get anything like that. That's like one of the worst case scenarios. It's just disgusting. All right, but basically that's what it all works out to, because you have to bring it back and then go forward to actually, it's like a weird subtraction problem. All right, number 8. You're given these 3 coordinates, cross-section problem, all right? And you're doing it perpendicular to the y-axis. Rare. We don't see a lot of these, but let's still do it just in case you ever did see one. So here are your points, just graphed on decimals. You don't need to graph on decimals. I just did because it gives a nice visual, all right? And so basically what you're doing is all of your cross section. So you're looking down at this thing, you're looking down at it, and everything that's coming up at you are semicircles. So you have semicircles, all right? Semicircles. So you want to basically sweep this thing, but we're sweeping it in the y direction. So that means we're doing a dy, all right? We're sweeping an area. All right, the areas are semicircles. Semicircles are 1/2 times pi r squared. And we're doing in the y direction, all right? So my smallest y is 0. My big Y is 8. So really you're sweeping up, but it's sweeping in the Y direction. Then your R needs to be found, all right? Well, let's figure out what our R is. Our R is this distance right here. It's from the y-axis over to this line. Well, let's figure out what this line is. This line would be y equals negative 2x plus 8. But we want it in terms of y, not x. So we're going to solve for x. So it's y minus 8 equals negative 2x, or x is going to equal 8 minus y all divided by 2. That's my r. So take that thing, plug it in here, square it, multiply it times 1/2 pi, and you didn't actually have to find the full answer in this case. They actually put it up there in for c. When you clean it up, you get c as your answer. For number 9, you're rotating around the line x equals 4. Here's another one of those gross ones where you're rotating around something that's just kind of, off in no man's land. Here it is. So here you're rotating it around 4. All right. So for these ones, since it's over 4, it's always going to be 4 minus whatever your function is. Always. All right. So you do 4 minus your function. That would be your r value. Even though it looks like you're adding a negative. So that would give you that positive part, just so you know. So you're finding the area inside of here, rotated around to this other side. So it would look pretty goofy, but it would be something like this, and this would be rotated around. All right. So it's still, you're sweeping along the y. So if you're sweeping along the y, it's dy. dy. Your smallest y value is negative 1. Your maximum y value in this case is 8. Again, decimals is great. Found those for me. I didn't have to do any work. All right. And then your values for so it's pi big R squared minus pi little r squared. Your big R is going to be 4 minus this function here. Well, that function, when you solve for it, you would get x squared equals 8 minus y. So x is going to equal plus or minus the square root of 8 minus y. This would be the positive part over here. We want the negative one. All right. So we want the negative square root of 8 minus y. That gives me my big R from here all the way to the outermost one. And my little r is just 4 minus this guy in terms of y. If you solve that in terms of y, you end up with, looks like y minus 8 over 3. That's what x equals. So you get y minus 8 over 3. And this is another one of those ones where you just have to clean it up and find the match. And when you clean it up and find the match, it ends up being, you have to do a little bit of arithmetic to find this part, but you end up getting C as your answer. Again, disgusting problem. I don't see this coming up on the actual AP, but that's how you solve a problem like that. Last one. What integral gives you the volume of a solid with a base of a circle, diameter of 6, so it has a radius of 3, centered at the origin, where everything, all the cross sections are perpendicular to the x-axis, and they are equilateral triangles. So here's what a circle centered at the origin with a radius of 3. It's just x squared plus y squared equals 9. That's the equation. You're doing cross sections along the x-axis, so any cross section like this would come up out of the page at you. All right, and they are equilateral triangles. All right, cross sections make equilateral triangles. All right, so it's kind of a weird shape here. You're sweeping along the x. All right, if you're sweeping along the x, it's dx. That's what an x looks like. Your x values are going from negative 3 to positive 3. Right. And then this is area of an equilateral triangle. The area of an equilateral triangle, if you don't remember, is s squared root 3 divided by 4. S is the entire side length. All right. So I've got my root 3. I've got my divided by 4. I want my s squared. My s squared is this entire distance. All right. So I need to find the top distance to my function and double it. So I need to solve this in terms of x. I want everything in terms of x. So that would be y is equal to the plus or minus the square root of 9 minus x squared. It's the plus because it's the top part. I don't want the bottom part. So it's 9 minus x squared square rooted with a 2 out front because I need the top and I need to double it to get my whole, that's my whole side length. I take that whole side length, I plug it into this thing, that's square root 3 over 4, which gives me that. And now I just clean it up. You're squaring the 2, so the 2 squared is 4, so that cancels with the bottom. You're squaring a square root, so that square root goes away, and it just becomes 9 minus x squared, radical 3, which is E. That's it. Whoo-wee! All right. Hope you enjoyed it. Bye.